Hello, grade 9. How are you today? I hope you all are safe and well. We studied before our last lesson about making salts using acids and alkalis, and we said this is neutralization reaction. We can react acid and alkali, neutralize them, and get salt and water. And we said that we can use an indicator and heat to remove the water to get the crystals of the salt as sodium chloride. And we said about sodium chloride, we can use it to react sodium carbonate and get the sodium chloride with reaction of this sodium carbonate with the dilute hydrochloric acid to get salt and water. Today we will talk about making salts or fertilizers. So open your books on page 206, grab your highlighters and follow me please. Making salts, fertilizers. Why add fertilizers? We all know that farmers are using fertilizers to their plants to increase the yield or to increase to improve the production of the plants and get more healthy plants. So that's why they are adding fertilizers to the plants. Plants use water and carbon dioxide from the air to make glucose. Glucose is a compound made up of the element carbon, hydrogen, and oxygen. Its formula is C6H12O6. I know someone that loves this formula. So this is the glucose. Plants need other elements too. They need nitrogen to make proteins. They need phosphorus to make flowers and seeds. They need potassium to protect them against diseases. If you can remember, we studied about these elements that the plant needs, and the lack of these elements can cause the yellowish brown color to the leaves, falling leaves, old shrinked leaves, and it can damage the plants. So these are essential for these elements are essential for the plant's growth, and they can get them from the soil by their roots. Plants get nitrogen, phosphorus, and potassium minerals from the soil. Farmers increase crop yields by adding fertilizer to the soil. Some fertilizers, such as manure or compost, occur naturally. Other fertilizers are made in factories. So here these elements, as we said, that they can take them from the soil, but the farmers, they are adding these fertilizers or increase the amount of these elements in the soil by adding these fertilizers to increase the yields which is the production of these plants, the production of the flowers, the seeds, the fruits. And we have example like manure and compost. With the manure, both of them are fertilizers, but manure is a fertilizer that made by animals' waste, which is like organic animals' waste, and the compost is like vegetables, plants already decomposed. So these both types, they can occur naturally, or you can find them naturally, but other fertilizers that is being made in factories. So how can we make these fertilizers in the factory? Most nitrogen fertilizers are made from ammonia. Ammonia is a compound of nitrogen and hydrogen. Its formula is NH3. Ammonia dissolves in water to make an alkaline solution. In the laboratory, you can react ammonia solution with acid. These neutralization reactions make salts. The salts are used as fertilizers. So when we dissolve this ammonia powder in water, it gives us alkaline solution. So we need it as a salt. So we need to react it with an acid, which is neutralize it. We're using an acid to get the salt and water, and then we can get them as crystals, as salt crystals. Which salts? So we can act ammonia with different acids, okay, but which salt is suitable as fertilizers? We need to choose the reactants as usual. So the equation show the reactions of ammonia solution with acids. We have ammonia plus sulfuric acid react to give us ammonium sulfate plus water. Ammonia plus hydrochloric acid give us ammonium chloride plus water. Ammonia plus nitric acid gives us ammonium nitrate plus water. So which one of them we should choose? Here, ammonium nitrate contains more nitrogen than the other ammonium salts. So to get the best nitrogen percentage, because nitrogen is essential for the plants. So we need to react ammonia plus nitric acid to get ammonium nitrate, because this is the best salt that contains more nitrogen than other ammonium salts. Farmers add ammonium sulfate to alkaline soil. The salt provides nitrogen for plant growth and makes the soil less acidic. So here farmers, they are reacting, or they are adding the ammonium sulfate to alkaline soil. We said actually the ammonium sulfate is acidic, and to alkaline soil, so they can neutralize it a little bit, and they can make the soil less acidic. And here they need to provide the nitrogen, this salt, nitrogen salt, for the plant growth. Making ammonium sulfate. So how can they make ammonium sulfate in the lab? Madhu plans to make ammonium sulfate. He pours 25 cubic centimeter of ammonia solution into a conical flask. Most of our reactions, or most of the reactions that we can make, it's better to make it in a conical flask, because it has the shape is suitable and you can move it easily. You can stir, or you can move it even to mix the mixture inside it easily without splashing the solution on your hands. He pours sulfuric acid into a burette. As we said before, this is a burette, okay, and with the tab here, this is the tab. We can use it to drop the solution, or to drop the acids, or the mixture, or the alkali, drop by drop, or we can add it slowly, or we can add it fast. But we are using it to measure the liquids first, and we can use it because we can control the opening of the tap and closing the tap. So he used this burette over the conical flask. Conical flask contains dilute ammonia solution, and the burette contains dilute sulfuric acid. So here, Madhu adds 1 cubic centimeter of acid to the ammonia solution in the flask. The acid reacts with some of the ammonia solution. We said ammonia solution is alkali. Madhu removes a drop of the mixture by using this pipette. He drops it onto blue litmus paper. The paper remains blue. The flask contains some ammonia solution that has not reacted. So what does it mean for the paper to remain blue? That means the solution is still alkaline, because we said that litmus paper is color, or the indicator color is blue if it's alkaline, and red if it's acid. So he took one drop and he dropped it on the litmus paper, and he found that it is still blue. Then he repeats the step above several times. He adds more and more acid. Eventually the litmus goes red. Madhu has now added enough acid to neutralize all the ammonia. So why he just like found it, or he saw that it's blue? Because there is some of the ammonia solution is not reacted, is in the container or in the flask, or is not reacted with the sulfuric acid. So that's why it remains blue. But when he added the right amount of the acid, he neutralized it, and he found that the litmus paper color changed. The flask now contains a mixture of ammonium sulfate and water. There is a tiny bit extra acid too. So how he found that there is a tiny bit of extra acid too? Because the paper, or the litmus paper, changed into the red color. That means there is an extra acid. So now he neutralized it, and he got the ammonium sulfate and the water also. So when we studied about the making salts, we said we have only one step, or two steps, not one, after getting the salt and water, which is, can you think about it for a second? Okay, I think your answers are correct. Okay, so how he could remove the water? By using evaporation process over a water bath. So next step, as usual, take a water bath, a beaker, and evaporating dish, place your mixture in it, and start to heat the mixture over this water bath. But we need to evaporate it at a specific point until half of the mixture is evaporated. Then we need to place it in a very warm room and leave it for days. Then we can get the crystals. So let's go to the next page and see the rest. Separating ammonium sulfate from the mixture. Madhu uses evaporation to remove water from the ammonium sulfate solution. Here we have the water bath, we have the evaporating dish with the mixture, and we have Bunsen burner. When about half of the water has evaporated, Madhu stops heating. He leaves the ammonium sulfate solution in a warm place. The rest of the water evaporates, ammonium sulfate crystals remain. So this is the same process if we got salt and water inside inside the mixture. Fertilizer production. We use huge amounts of fertilizer. One common fertilizer that is made from ammonia is urea. In 2009, factories made about 190 million tons of urea. The pie chart shows the 5 countries that produced the most urea. So 190,000 million tons of urea, this is a lot. But let's see which country that produced the most urea. We have here the pie chart, as you can see, or as we studied before, that we can use pie chart for percentage, or like for data that uses numbers, or categorized names, or categories, we can name them. Okay, so here we have China that produces 33%, and comes after it India 13%, Then Indonesia 5%, Russia 4%, and USA 4%, and the rest of the world 41%. So the most or the biggest production of, or the most production of urea, that here in China. So now let's go to the summary of the lesson and see what do we have. Making salts, fertilizers. Ammonium nitrate and ammonium sulfate are useful fertilizers. And we said glucose formula is C6H12O6. Ammonia is a compound of nitrogen and hydrogen. Its formula is NH3. Ammonia plus sulfuric acid gives ammonium sulfate plus water, and ammonia plus nitric acid give us ammonium nitrate plus water. So this was all about making salts or fertilizers. I hope you understood the lesson. If you have any question, please write it down, and don't forget to write these notes in your notebooks. And don't forget the yellow box too. I hope to see you soon, and we will meet in a new lesson. Bye bye.